Okay, hi everyone. My name is Michele Stieven. I am an Angular GDE, and I am a freelance consultant, and this talk is called Consistent UIs with Angular, RxJS, and NgRx. Academia.dev is my website. It is where I post some of my articles in Italian and video courses in Italian. So if you're from Italy, feel free to check them out. But as usual, in these events, I really don't have time to talk about myself because there's a lot I want to talk about. So today, I'd like to talk about consistent UIs. And when I say consistent, I'm not talking about CSS and styling, but I'm talking about behavior. We, as developers, need to build solid interfaces. And they must behave like the user expects them to. So we don't want the user to feel frustrated because what they see on the screen doesn't correspond to what they expected. One of the good things about being a consultant is that you see a lot of stuff, especially broken stuff. So as you can imagine, I'm pretty much always surrounded by errors and bad practices. So this is me and this is my life. But once you see enough bad things, you start to catalog them into macro groups. And these are, in my opinion, some of the most important traits of inconsistent UIs. These are the source of frustration that I see daily, not only in my job, but also when I surf the internet every day. I'm sure many of you will agree with me when I say that most apps and websites nowadays are full of bugs. These bugs can usually be divided into two groups, as you can see: synchronization issues and side effect issues. For example, our templates could go out of sync, or even two different components could go out of sync. Or we could have unexpected side effects in our app, such as duplicated calls, calls in flashing states, calls which are made out of order, causing wrong results on the UI, or even calls that get cancelled by mistake, which give no visual feedback to the user. So in this talk, I'll give you 5 pieces of advice on how to design your Angular application in order to hopefully avoid situations like this. So this is my first piece of advice: design to forget. What the hell is he talking about? Let me explain with an example. So imagine this page with an invoice which can be modified, okay? So as you can see, the invoice has multiple fields, and every line has a quantity expressed in hours and a total. And below that, we have a list, a total of all the invoice, which is a read-only field, typically, which should be calculated automatically. Now, what happens if one of these lines changes? Well, the total should automatically reflect that, but sometimes that doesn't happen. Typically, beginner developers write code like this. So they create a variable for the total, they initialize it, and then inside a callback, when the user changes something, when they change the field, they recalculate the total and reassign it to the variable. This is a great problem, so remember what I'm about to tell you when you see something like this. The problem is that there may be other actions that should cause the total to update. Perhaps not today, but in the future, there might be. So in a few weeks, when you add a new field or a new button on the page, you'll have to remember to do the same thing. Otherwise, your app will be half broken. It will be inconsistent. Other than that, analyzing this component has become more difficult, because when I read about the total property, I cannot see what it is, what it does. I have to manually scroll through the entire component in order to understand it. It's also important to note that you don't solve this by creating a function called recalculate total, because you'd still have to remember to call that function every time. So we have scattered dependencies across all of our components, and we have duplicated code all over the place. Moreover, if our app is not future-proof, because we are not allowing ourselves to forget about recalculating the total. As soon as we forget it once, the app becomes frustrating. But fortunately, now in v17, we have Angular signals, which are designed to store some data and automatically notify all of the derived states. Now you know how, thanks to Daniela. They notify all the derived states of the data. So we have our states, which are our signals, and then we have a derived states, which is created using computed. What's important here is that with computed, we are defining a declarative recipe for the state. I can now immediately see how the total is calculated, and I don't need to update the total in any other part of the component. So this is what I mean with design to forget. I have structured my application, my component, so that I'm free to forget about that total, because I won't touch it ever again. Of course, in my example, I was talking about a form. So you can do the same thing with reactive forms and observables in RxJS by using either the pipe method on the observable or by using the combine latest creation operator. In this case, I always suggest creating a custom value changes creation operator rather than using the built-in value changes observable, because if you know what I'm talking about, it's a hot observable, so you could theoretically run into strange problems. If you want to know more about it, I will leave the link in the slides later. Piece of advice number 2, design for collaboration. What do I mean? Let's see this example. Now, next to the form, you have a sidebar with the list of invoices. In this case, the third one is selected. So on the right side, that's the one I'm editing, right? So let's see what could go wrong here. Imagine this. The user modifies something on the right, receives a success message, but then they don't see the update reflected on the left side. So the title is still the same as before the update. Once again, we don't have a consistent UI because we have 2 different titles for the same invoice. This is a very frequent source of frustration because the view is usually divided into 2 separate routes nested within each other. So we have 2 distinct components, and they typically can't communicate via template because they don't see each other. Because, of course, there's a router outlet in the middle acting as a wall. So the first component cannot pass any input to the second one, and it cannot listen to any events. So they both have their own states, and they're not collaborating. There are a few solutions to this. The first one is to avoid duplicating states and keeping just one state variable in a service or inside a state manager. This is what we call a single source of truth, because the data is not duplicated in our code. Another solution is to keep the 2 variables separated, but keep them in sync manually. This is, of course, more difficult, but it's easier if both variables are in the same place, for example, a service. So for those of you who are using NgRx, just to illustrate, this is an example where I use a reducer to listen to a save invoice success action in order to update the list of the invoices. And here on the bottom, we have another approach, which is to completely refetch the list. And this is often useful when changing one invoice could potentially change other invoices as well. In this case, we say that a mutation has side effects. This is a key concept, for example, in TanStack query, which was React query, or even frameworks like Remix for React. With that said, another valid solution, which I'll briefly mention, is to use something like, of course, TanStack query, which is, again, a library which provides a way to imperatively invalidate multiple API calls all at once and refetch the resources automatically. Originally, it was a React query. Now, there's even an Angular implementation, which you'll find on its website. So if you like this approach, feel free to check it out and go for it. Then, piece of advice number 3, design to forgive. Once again, let me explain. Imagine someone who just recently understood how a computer works. My mom could be the perfect example for this. So she understood that in order to start an application, a program, she must double-click the program icon. So now, of course, she doesn't expect one click to do anything. So now she clicks everything twice. So you might argue that that's not how you're supposed to use my application, right? But really, it's better to just design our app in order to forgive this kind of behavior. Okay. Because you'll also forgive those who click twice, accidentally, or even those who have a faulty mouse. Let's go back to our example. This time we have a delete button to delete the current invoice. What do we do in these cases? This is what we normally do. On the event handler, we call the service, which in turn calls the API in order to delete the invoice. However, there's a big, big problem here. I'm talking about back pressure. What is back pressure? It's when the user clicks on the button before the previous call has finished. As you can imagine, my mom would see an error here. One solution is to create a variable which stores the state of our query and use that to either disable the button when the query is running, or we could check every time before creating a new request. However, these solutions are bloating our component with unwanted noise. And by simply disabling a button, we would tie our business logic to our UI. We are not designing to forget anymore. Remember previously? If someone has a charger, I think my laptop is out of battery. USB-C. No, Mac. Sorry. In this regard, by the way, I suggest a wonderful article by David K. Piano on Dev2, which is called, it's quite an old article, but thank you, it's always valid. It's called Disabling a Button is Not App Logic. So if you want to know more about the topic, check it out. It's about the importance of forgetting. Sorry. Okay, instead, we can create a subject. How many of you know what a subject is? Okay, a lot of you. Perfect. So, as you already know, it's an observable, which is like an event emitter. Okay, and on the template, we can emit directly through that subject. In this case, we don't need any value, so it's void, because we are talking about the current invoice of the page. So we already know its ID. Now we can create an effect. Inside the constructor, we can listen to that subject and use a flattening operator which automatically handles back pressure. In this case, the correct one is exhaust map. But those of you who know RxJS know that there are 4 major flattening operators with different behaviors, and you have to choose the right one for the job. And notice that I'm using a new Angular feature, which is an operator called take-until-destroyed, which simplifies the code quite a bit by unsubscribing manually, automatically when the component is destroyed. By the way, it has been announced just a couple of days ago, in fact, I had to redo the slides, that in v17 of NgRx, there will be a new package inside the monorepo called NgRx signals, which will offer a new way to structure your states with signals. Let me show you very briefly how it works. So as you can see, you can define your store with this new function called signal store. You can optionally use this provided in root, this is optional, in order to make it a global store. Otherwise, you will need to provide it inside a component, just like with component store, if you know what it is. Oops. Okay, then you need to initialize it with an initial state. And this will tell the library the shape of your store. then you will be able to use it as a signal. Then you can calculate derived states with this with computed function. Of course, each state will be calculated only when necessary, because we are dealing with signals. Then you can create methods for this store. This way, you can really take a lot of code out of your components and put it in a single place. And of course, inside these methods, you can read and write to the store. You can even use this new function, which is called Rx method, in order to define an asynchronous method by using RxJS, as you already know it. As you can see in this example, this is just an increment method, but with a debounce time operator applied to it. So you see how you could take this, this code instead of putting it into the constructor as we saw before. And finally, you can specify a list of hooks, which are methods that the library automatically calls for you when necessary. So this is even more code that you can take out of your components. Piece of advice number 4, design to change. Design your application so that it can be easy to change in the future. Once again, we have our UI, but now we have a save button. Let's see how we'd handle this situation with NgRx and RxJS. This is a typical effect, which is responsible for saving the invoice. You've seen it many times, I'm sure. When we receive the save invoice action, we make the API call, and then, if successful, we map the result with a save invoice success action, or we catch the error. In this case, we are using switch map to handle the back pressure, so that if the user modifies the invoice a second time before the first call has finished, the first call will be cancelled. It seems like switch map is the right choice for this, right? But there's a problem. Tomorrow, your UI changes. And on the left side of your app, it will be possible to modify each invoice title directly without selecting it and opening it. This means that a fast user, could edit 2 different invoices in a very short period of time. And that would break our app since we're using switch map. Because now, when the user updates the second invoice, if the previous call hasn't finished, it won't be updated in our UI, even though it will be updated on the server because the call has been made nonetheless. In this case, we can solve the problem by introducing the group by operator. It's a really wonderful tool which basically splits a single effect into many effects. In this example, 1 for each invoice ID, so that the effect for one invoice doesn't impact the same effect for another invoice. Unfortunately, I don't have much time to go into detail about this, and for this, I will suggest a wonderful video, which is called What Groups By in Vegas Stays in Vegas by Mike Ryan and Sam Julian, available on YouTube. Of course, this is not just related to NgRx store. Here we have the same example with NgRx component store. And as you can see, they're almost the exact code. Okay, we just change the beginning and the end. Okay, with map and catch error become the tap response operator. And the input of the effect is a bit different, but the theory is the same. So really, this is a technique that you can use even without NgRx. You just need to be using RxJS. Final advice, number 5, the final one, design for failure. So for this, I don't want to show any code, just some recommendations. If you're using RxJS, remember to catch the errors when you don't want to react to them. If, however, you want to react to them and show something to the user, remember that you can use the tap operator for that, or even better, if you can, the subscribe method on the observable. And finally, remember that you can always use try-catch as a last resort. In conclusion, don't let your application crash. Let the errors become part of the state of the app. It doesn't matter if you want the user to see them. It can be a personal choice. What matters is that you treat them as part of the state of your application, so your app doesn't crash. So, a quick summary. Allow yourself to forget to update derived states by using declarative code. Allow yourself to collaborate with other people, perhaps, who may be working on the same page of your application by sharing a common state. Allow your app to forgive strange behaviors by the user. Allow the app to change in a few weeks or months by thinking about how the app could evolve in the future. And finally, remember to treat errors as part of the application state. So, treat them carefully. This is it. I hope you liked it. If you want to contact me, you know where to find me. And if you want to have the slides of this talk, you will find them on this GitHub repo. And thank you.
Thank you, Michele. You are perfectly on time. So if you have a question, we can take a couple of questions if you want.
I'll be out here as well if you want to talk to me.
I don't see hands raised this time. Okay.
Okay. Not even him?
Ask something, I don't know. I know you can. You were watching me like, should I? Yes.
Hello. Thank you.
Hello.
I'm already famous for this. I wanted to ask about edge cases.
Okay.
It was really interesting, the one for back pressure. But does any other edge case comes into mind? Because they are pretty specific, so you have to to think about the specific solution for that kind of problem.
Yeah, it's usually a copy-paste. So whenever you see a subscribe inside an event handler, that's usually the problem. So it's pretty much a copy-paste. You may change the operator. There are 4 flattening operators, but the problem is the same. So I don't know if that's the answer to your question.
Yeah.
Or
no, well, I was thinking more about there's the double-click issue, for example.
Okay.
And maybe another kind of category of edge cases.
There may be.
If it comes to mind, I think.
Okay, here I try to cover the most, the ones I see the most. Of course, there are a lot more. These are the ones that I always, when the client says I have this problem with duplicated code, okay, I know what it is. I just need to find the right file and the right line. But I know what the problem is.
Okay.
So this is the most common.
Okay. Thank you.
Nothing.
Okay. Thank you.
Yeah.
Okay. Thank you, Michele. Please give a big round of applause for Michele. Michele Stieven.